Welcome back to another video, and today we'll be working the January 2022 paper 2 question 2. So question 2a says factorize completely. So we know that when we're looking at an expression and factorizing it, want to identify what kind of factorization is taking place. We're usually in most cases looking for what is common between the terms that are given. So we're looking for what is the common term in each term. So from this 3n square, what is in 3n square that is also common in 15np? And in this case, we can see that the common term 3, because 3 can go into 3 and the 3 can also go into 15. And n is also common, as n can go into n square and n can go into np. So the common term, the common factor, it goes on the outside, and then what is not common, what I like to say is that it goes inside the bracket. So the common factor go on the outside of the bracket, and what is not common go on the inside. So now we're performing what we can say a simple step of division. So you're dividing the common factor into each term that was given in the question. So you're saying 3n into 3n squared, and that will leave us with n, and then 3n into 15np. So basically, it will be a positive term that comes next. So you're saying 3 into 15 goes 5 times, and n into np. So the n's cancel out, and that will basically leave us with p. So therefore, in factorizing this expression, our answer will be 3n outside of the bracket, then in bracket n plus 5p. Now the beautiful thing about factorization and algebra question like this is that we can even rework our answer, and we'll see that we get the expression that was given in the question. Part B says the diagram below shows a quadrilateral with the length of its sides written in terms of x. So 4 sides, we have 15 minus 2x, 3x minus 7, 2x plus 5, and 2x minus 1. And it says, write an expression in terms of x for the perimeter of the quadrilateral. Express your answer in its simplest form. So we're writing an expression, and we know that when it comes down to expression, it doesn't usually have any equal sign. So you won't have the terms that are on the quadrilateral being equal to anything. So therefore, if we write an expression, what we'll have is 15. So we're using each term that is on the quadrilateral. So we'll have 15 minus 2x plus, then we're coming here, 3x minus 7 plus, then we're coming here, 2x plus 5, then we're coming here, which is now 2x minus 1. And what we'll do in order to simplify this expression is to group our like terms. So we'll put all our numbers, all our constants together, and then put the variables together. So what we'll have is, and remember that when you're rewriting expressions, the sign that is in front of each term belongs to it. It holds it dear to its heart. So for example, this 2x is a negative 2x. So anywhere this 2x goes, this negative sign or the subtraction sign will follow it. The same thing for this 3x, the same thing for this minus 7. So if we're rewriting, I'm writing the constants first. So we'll have 15, then minus 7, then a plus 5, then a minus 1. And now we've taken care of all those, we can now start writing with the one with the variables and the coefficients. So we'll have a minus 2x, then a plus 3x, then a plus 2x, then another plus 2x. And now we can go ahead and simplify. So 15 minus 7, that will leave us with 8, 8 plus 5, that will give us 13, and 13 minus 1, that will give us 12. So from our constants, we have 12. Then from the variables with the coefficients, now we have, so this is a minus 2x plus 3, so that will leave us with 1x, plus 2, that will give us 3x, plus 2, and that will give us a plus 5x. So our simplified expression in terms of x for this quadrilateral in terms of the perimeter would be 12 plus 5x. So all you're doing, you're taking the terms that are on the quadrilateral and then grouping your like terms and simplifying. So this is just a simple case of algebra. Part 2 now says the perimeter of the quadrilateral is 32 centimeters. Find the length of the longest side of the quadrilateral. So the perimeter is 32 centimeters and they want us to find the longest side. But what we know is that each side have an unknown variable, which is x. So therefore, for us to can find the longest side or give a solid figure for the longest side, we'd have to work out what is the value for x. So from our simplified expression here, we're going to turn it into an equation. So we're going to have 12 plus 5x is equal to 32. So it is this 32 centimeters here. Now we're going to solve for x. So at first I'm going to subtract 12 from both sides of the equation. So what I'll have is 5x is equal to 32 minus 12. So therefore 32 minus 12, 5x is equal to 20. Now I'm going to divide both sides of the equation by 5. So remember this 5 is multiplying here. So in order to get rid of it, I'm going to divide both sides of the equation by 5. So what we'll have is x is equal to 20 divided by 5. And now we can go ahead and solve for x. So 20 divided by 5, and that will leave us with 4. So now we know the value for x, which is 4. And we can now look at our quadrilateral, or we can substitute the value for x into each side and work it out. But let's say we could look at it and we could say that this side is the longest side on our quadrilateral. But also we know that usually in math, there's usually a disclaimer that says, it's not draw to the exact size or anything of the sort. So we're going to do it both ways, or we can just substitute x into all 4 sides, all the expressions are on all 4 sides, and then that would make it, we are sure that that side is the longest side. So these are the sides here. So we had 15 minus x, 3x minus 7, 2x plus 5, and 2x minus 1. So we're now substituting x into each expression. So for the first expression, it was 15 minus 2x. So what that would be is 15 minus 2 multiplied by 4. That would give us 15 minus 8. And that length, or that side, is equal to 7 centimeters. The next side, the next expression was, here, 3x minus 7. So it is 3x minus 7. So it is 3 multiplied by 4 minus 7. So that is 3 times 4 is 12, 12 minus 7, and that is equal to 5 centimeters. Now the next expression was, so let's go back, 2x plus 5. So we have 2x plus 5. So again, substituting, so it is 2 multiplied by 4 plus 5. So 2 times 4 is 8, so it is 8 plus 5, and that will give us 13 centimeters. And now going back for the last expression, which was 2x minus 1. So it is 2x minus 1, so that will give us 2 multiplied by 4 minus 1. And 2 times 4 is 8, so it is 8 minus 1, which will give us 7 centimeters. So even though we could have went ahead, so you'll see that indeed, as we predicted, that this side would have been the longest with this expression 2x plus 5, which gave us the 13 centimeters, even though it is quite visible from this diagram. When we worked it, we indeed proved our theory or our hypothesis that side, that expression would have been the longest. So therefore, the longest side, as the question asks us to solve, so find the length of the longest side. The length of the longest side is 13 centimeters. Therefore, the longest side is. So part C says determine all the integer values of x which satisfy the inequality. So you can either work it piece by piece by using this middle term being greater than -1 as one part by itself, and then the same middle term being less than 5, and work that by itself, and in each case you'll be solving for the value of x. Or you can work it in one by whatever you do to one side, you do to the left side. So whatever you're doing to the left side, you're doing it to the right side, with the middle term will in the end be the x value. So we're solving for x and making x be in the middle with a number on the left and a number on the right. So we're removing everything from in the middle. So we're starting with the 3, so it is dividing here. So we will multiply each side by 3. So we're going to multiply this by 3, multiply this by 3. So what we'll have is -1 being multiplied by 3. Then we have our less than sign. So what will remain there would be 2 minus 4x, and then less than sign, and 5 multiplied by 3. So we're multiplying both sides of the inequality by whatever value that you're removing from the middle, because the aim is to have only x remain in the middle. So when we do that, we'll have 3 times -1 will leave us with -3 is less than 2 minus 4x, which is less than 5 times 3 will leave us with 15. Next, we're going to remove the 2. So whenever, to get rid of the 2, it is adding here. So on either side of the equation, we're basically subtracting 2 from both sides of the inequality. I think I said equation earlier, I meant inequality. So we'll have -3 minus 2 is less than minus 4x, because that is what now remains after we remove the 2, is less than 15 minus 2. So -3 minus 2, what we'll have there will be a -5 is less than minus 4x, which is less than 15 minus 2 will leave us with 13. Now the only value that remains to be removed would be the -4. So it is multiplying here. So when it comes across each side of the inequality, basically we're dividing. So we're dividing each side of the inequality by -4. So what we'll have is -5 divided by -4. And now what we'll have, all right, so let's rewrite that a bit. Let's put some brackets. So we'll have -5 divided by -4, and less than sign, less than x, which is less than 13 divided by -4. Now, what I want you to remember is that whenever you are dividing by a negative number in inequality, so whenever you are dividing by a negative number in inequality, it always causes these signs to flip. So this was less, x is greater than this term here, it will become this term being greater than x, and then x will be greater than this term. So that is the reaction that dividing by a negative number causes. It flips the direction of our inequalities. So when we have -5 divided by -4, what we'll have here is, so if you put that in your calculator, -5 divided by -4, you'll have a positive 1.25 is greater than. So because we're dividing by a negative number, the sign flips. So it's like a reaction thing. So it's greater than x, cause and effect. So, and then this sign again will flip, so greater than here, and 13 divided by -4, that will give us a -3.25. So that is our answer. And we can basically now rewrite it as -3.25 is less than x, which is less than, which x being less than 1.25. So these two last equations, or inequalities rather, these last two inequalities are the same thing, because this is saying x is greater than -3.25. It's the same thing here. X is greater than -3.25. This is saying x is less than 1.25. Same thing here. X is less than 1.25. So we now have the range that can satisfy this inequality. Therefore, all the integer values, so that is what the question asks us for, the integer values, all our integer values would be, so after -3.25, the next integer would have been -3, then -2, because remember, x is greater than -3.25, so we're going up. Then we have -1, 0, and then as we approach, we need to check back this part of the inequality. It says x is less than 1.25. So the only other integer that would come here is 1. And this would be the range of values that satisfy this inequality for the integer values of x. So thank you for joining us, and we will see you in another video.